On July 1st, 2025, astronomers discovered an object older than Earth itself racing through our solar system at 137,000 miles per hour. And when they later analyzed its chemistry, they would find materials that matched signatures only seen in human-made industrial alloys, never in nature. Scientists at the Atlas Survey Facility in Rio Hurtado, Chile, stared at their screens in disbelief as the data confirmed what seemed impossible. This wasn't just another comet. This was 3I Atlas, the third confirmed interstellar object ever detected. And its hyperbolic trajectory revealed it was merely passing through, a cosmic wanderer that had never belonged to our solar family. But the real shock came when astronomers traced its path backward through time and space. University of Oxford researcher Matthew Hopkins and his team analyzed the object's steep trajectory through the galaxy, and their statistical models pointed to an origin that made veteran astronomers pause: the Milky Way's thick disk, a region of ancient stars orbiting above and below the galactic plane where our sun resides. If their calculations were correct, 3I Atlas could be between 7.6 and 14 billion years old, older than our 4.6 billion-year-old solar system by billions of years. Hopkins himself stated the unprecedented nature of this discovery. This is very likely to be the oldest comet we have ever seen. When NASA's Transiting Exoplanet Survey satellite reviewed its archived footage, scientists discovered something even more unsettling. TESS had been watching 3I Atlas since May 7, 2025, 2 full months before its official discovery, when the object was 6.4 astronomical units from the Sun, farther out than Jupiter. The comet had been active, releasing gases and dust, when it should have been frozen solid at that distance. What kind of ancient ice could sublimate so far from the Sun's warmth? What volatile materials had this traveler collected during its billions of years drifting between the stars? By July 21st, the Hubble Space Telescope captured the first detailed images of 3I Atlas from 277 million miles away. The photographs revealed a teardrop-shaped cocoon of dust streaming from its nucleus, a halo of material being shed as the ancient visitor awakened from its eon-long slumber. Professor Chris Lintott, co-author of the study, captured the magnitude of what humanity was witnessing. This is an object from a part of the galaxy we've never seen up close before. But when scientists analyzed what this ancient wanderer was actually made of, they discovered chemistry that would make even the most skeptical astronomers question everything they knew about comets, and whether 3I Atlas was entirely natural at all. When astronomers at Hawaii's Keck-2 telescope trained their instruments on 3I Atlas in late August 2025, they detected something that defied every known law of cosmic chemistry: cyanide and nickel billowing from the comet's surface, but no iron. In every comet ever studied, in every supernova remnant, in every stellar formation process known to science, nickel and iron appear together because they're forged simultaneously in the hearts of dying stars. The only other place this chemical signature had ever been documented was in industrially produced nickel alloys on Earth. Harvard astrophysicist Avi Loeb stared at the data and noted the substance was never found in nature but known from human-made materials. What could separate these elements billions of years ago? But the chemical anomalies had only just begun to reveal themselves. On August 6, 2025, when the James Webb Space Telescope aimed its infrared spectrograph at 3I Atlas from over 270 million miles away, it measured a carbon dioxide to water ratio of 8:1, the highest ever recorded in any comet, sitting 6 standard deviations above the normal range. NASA scientist Martin Cordner and his team at Goddard Space Flight Center confirmed what seemed impossible. This ancient traveler was wrapped in a fog of carbon dioxide so dense it defied every model of comet formation. Regular comets are dominated by water ice.
3I Atlas had inverted the fundamental chemistry of what a comet should be. The Webb data revealed production rates that told a disturbing story. 1.76 times 10 to the 27th molecules of carbon dioxide escaping per second, but only 2.19 times 10 to the 26th molecules of water, meaning carbon dioxide was doing the work that water normally does, lifting dust and gas from the surface. The physics had been turned inside out. Then came the observation that made even skeptical scientists pause. Multiple telescopes captured what observers called an anti-tail, a plume of material extending not away from the sun as radiation pressure demands, but toward it, defying the fundamental rules that govern every other comet. The Keck Observatory's detailed mapping revealed nickel concentrated in the innermost 594 kilometers around the nucleus, while cyanide spread much farther, to 841 kilometers. Both gases were flowing in two directions simultaneously, away from the sun and toward it. UCLA planetary astronomer Michael Bush proposed a fast-spinning, potentially unstable nucleus was ejecting heavy dust grains that didn't follow normal cometary physics. But that explanation only addressed the mechanics. It didn't explain the chemistry, the impossible ratios, the missing iron, or why an object billions of years old was behaving like nothing science had ever documented. As 3I Atlas raced toward its closest approach to the sun, the real question wasn't what it was doing. It was where such an impossible object could have come from, and whether humanity was ready for the answer. If you want to uncover more cosmic mysteries that challenge everything we know about the universe, subscribe to Dark Dimensions X and hit the bell icon, because what we're about to reveal next will make this chemistry look normal by comparison.
When Spanish astrophysicist Javier Pérez Couto traced 3I Atlas backward through 4.27 million years of galactic history, checking 62 nearby stars it should have encountered during its journey, he discovered something that made his blood run cold. None of them, not a single star, could explain where it came from or why it was moving at a record-breaking 130,000 miles per hour. His team at Spain's Universidad da Coruña had used data from the European Space Agency's now-retired Gaia Space Telescope to map every close pass, every gravitational tug, every stellar flyby that could have altered the ancient visitor's trajectory. The conclusion sent a chill through the astronomical community. Pérez Couto's statement was stark. We have found that none of the stars in the solar neighborhood can explain the trajectory and high velocity of 3I Atlas. Only a single star, measuring about 70% the mass of our Sun, showed any gravitational influence at all, and that impact was negligible, barely a whisper in the comet's billion-year voyage. The implications were staggering. The team concluded that 3I Atlas had not experienced any significant stellar flybys within the past 4 million years among all the stars contained in Gaia's massive database. This led them to a haunting conclusion. 3I Atlas is a very old object that has been traveling for billions of years, and that its origin belongs to the border of the thin disk, the mysterious frontier where the Milky Way's younger, metal-rich stars give way to the ancient thick disk, a region that ceased forming stars billions of years ago. The comet's path had been nudged countless times by stars, molecular clouds, even the spiral arms of the galaxy itself over its incomprehensible journey. Every gravitational encounter should have left traces, signatures that astronomers could follow like breadcrumbs back to its origin. But those breadcrumbs led nowhere. 3I Atlas cannot be traced back to its original parent star because it has been traveling around the Milky Way for billions of years, enough time to be mixed around with other stars, its original trajectory erased by eons of cosmic chaos.
University of Canterbury astronomer Michelle Bannister, studying the comet's estimated age of over 8 billion years, stated what others were thinking. It's from a star that's potentially not even there anymore.
The parent system that birthed this ancient traveler could have lived and died, its star exploding into a supernova or collapsing into a white dwarf long before Earth formed.
3I Atlas was a messenger from a stellar civilization that had vanished, a ghost carrying evidence of a world that no longer existed, hurtling through space with a velocity and origin that defied every attempt to explain it.
When Harvard astrophysicist Avi Loeb calculated the solar radiation that would hit 3I Atlas at perihelion, the number made his blood run cold. 33 gigawatts of power, equivalent to a third of all nuclear reactors operating in the United States, would bombard the comet's surface on October 29, 2025. If this ancient visitor carried anything artificial, any technology designed to harness stellar energy through what's known as an Oberth maneuver, perihelion would be the moment it activated. Loeb ranked 3I Atlas as a 4 on his scale measuring the probability of alien technology, noting, "The remote possibility of an Oberth maneuver must be considered seriously as a black swan event with a small probability, because of its huge implications for humanity." The eclipse of 3I Atlas by the Sun at perihelion would allow a spacecraft to conduct what Loeb and his colleagues called a clandestine reverse solar Oberth maneuver, an optimal high-thrust strategy for interstellar spacecraft to break and stay bound to the Sun, hidden from Earth's view. The timing seemed engineered. An optimal intercept of Earth would entail an arrival in late November or early December of 2025. Loeb tasked the research team of the Galileo Project observatories to check for any unusual activity of extraterrestrial technological objects near Earth in the coming months. October 3, 2025, while Earth slept unaware, 2 European spacecraft orbiting Mars turned their cameras toward a visitor that would pass within 30 million kilometers of the red planet, 9 times closer than it would ever come to our world. The European space agencies Mars Express and ExoMars Trace Gas Orbiter aimed instruments designed to photograph Martian geology at the ancient comet streaking through their sky. The data would take weeks to transmit back to Earth, but scientists knew this was humanity's closest view of an interstellar traveler, watched not from our world, but from another. By October 21st, as 3I Atlas passed directly behind the Sun from Earth's perspective, NOAA's GOES-19 weather satellite, designed to track hurricanes and storm systems, pivoted its CCOR-1 coronagraph to capture the comet during solar conjunction. On October 29, 2025, 3I Atlas reached perihelion, its closest approach to the Sun, at 130 million miles away. Behind the Sun's blinding glare, hidden from every telescope on Earth, the ancient visitor was exposed to more power than humanity generates in a month. Images from the Nordic Optical Telescope captured the transformation. The anti-tail that had defied physics for months had turned into a normal tail pointing away from the Sun. Loeb's colleague Adam Hibbard pointed out the unsettling possibility if the object was an alien spacecraft slowing down and the anti-tail was braking thrust, then this change in behavior could indicate the deceleration phase had ended. The real opportunity would come on December 19, 2025, when 3I Atlas would make its closest approach to Earth at 168 million miles away. 2 spacecraft, NASA's Europa Clipper and ESA's Asteroid Hera mission, might intersect the comet's mysterious anti-tail during their journeys, potentially passing through material from another star system. What would the data reveal? Had something changed during those 8 hidden days behind the Sun?
2 days ago, on October 29, 2025, 3I Atlas reached perihelion, its closest approach to the Sun, hidden behind the Sun's blinding glare where no telescope on Earth could watch it. For those 8 days, during the exact window Avi Loeb calculated for an alien spacecraft to conduct a secret Oberth maneuver, this ancient visitor was exposed to 33 gigawatts of solar radiation completely out of our sight. Right now, as you watch this, it's still hidden. The comet won't emerge into view again until mid-November, and when it does, astronomers will finally discover whether the anti-tail, the backwards-pointing plume that defied physics for months, has vanished. Whether it's behaving normally now, too normally. But what scientists already know is that they're witnessing something unprecedented in human history, a window into the pristine material of another solar system, helping scientists refine their models of what solar system formation can look like across the galaxy. Michelle Bannister captured the magnitude of what humanity had touched. That would mean 3I is the oldest macroscopic thing we've ever seen in the solar system. Not just the oldest visitor, but the oldest physical object human eyes had ever observed. Older than any meteorite, any moon rock, any fragment of cosmic debris ever studied. The leading theory suggests these ancient wanderers are ejected from protoplanetary disks, the swirling clouds of gas and dust around young stars where planets are born. David Jewett, who led the Hubble observations, explained the implication. We know that our solar system started with this disk, and then a lot of the stuff in the disk was lost. He was kicked out, 90 or 99% was ejected to the interstellar medium. Maybe the disk of the galaxy is full up with comets ejected that way, and if that's the case, there should be a hell of a lot of them. The galaxy might be teeming with billions of these time capsules drifting in the darkness between stars, carrying frozen samples of planetary birth from every era of cosmic history. Some scientists theorize that interstellar objects may serve as galactic couriers, transporting dust, ice, and organic molecules that seed young planetary systems. If true, 3I Atlas wasn't just a curiosity. It was evidence of chemical exchange between star systems, suggesting that the materials that built Earth, that sparked life in our oceans, might have arrived on similar ancient travelers billions of years ago. Jacqueline McCleary at Northeastern University framed the deeper question. Learning about 3I Atlas helps us understand why our solar system is so unique that it created the conditions for sentient life to exist. The International Asteroid Warning Network added 3I Atlas to its official observation list, noting, while it poses no threat, Comet 3I Atlas presents an excellent opportunity for the IAWN community to conduct an observing exercise given its prolonged visibility from Earth and its significant scientific interest. The Vera C. Rubin Observatory, beginning operations in late 2025, is expected to detect between 6 and 51 interstellar objects during its 10-year survey. The European Space Agency's Comet Interceptor mission, designed specifically to rendezvous with pristine comets, might one day chase down an interstellar visitor and return samples to Earth. Humanity would hold in its hands materials older than our world, forged in stellar furnaces that died before our sun ignited. But for now, 3I Atlas continues its billion-year journey back into the cosmic dark, carrying its impossible chemistry and untraceable origins away from the warmth of our sun. Somewhere in the depths of space, it will drift for another eon, perhaps encountering another star system, another civilization, another species staring up at the night sky and asking the same questions we asked. Where did you come from? What secrets do you carry? And in those 8 days, hidden behind the sun, did something awaken in you that we'll never know about until it's too late?